I find it kind of neat that when I said to swap out batteries at the very end of the last and reach to turn the camera off, the camera turned itself off. So if it caught my last statement, it was within a fraction of a second of the actual end of that video. Of course, the end came a little early because it was warning me. I didn't expect it to cut off that quickly. Then I swapped out my memory card rather than my battery, but fortunately I noticed that I'd done that before I swapped out the battery. So we're good. It only took a minute. Okay, so what kind of a shape is this? Well, in the XZ plane, you can verify very easily because we've done a number of them. This is just a circle of radius 2 that completes the circle every 2 pi units of t. Okay? So that's really easy. And in the I direction, along the y-axis, this is just motion along the y-axis at a speed of 5 units per second, or 5 units of distance per unit of time, whatever t stands for. 5 units of distance per unit of t. Okay? So what we have then is motion in the XZ plane that kind of looks like this, but we're moving along at 5 units per unit of t. If t is thought in seconds, at 5 distance units per second, so we're doing this. We're moving this way, but we're moving to the right. And that forms a helix, like an elongated spring. And between t equals 0 and t equals pi, we're moving how far? Well, we move halfway around the circle. So it's only like we're here and we go around this much of the helix. So it's like this much. We haven't done this part yet. How far do we move? Well, if we just stayed in the plane, circle of radius 2, we move through half a circle. We go through what? 2 pi radians. I mean, a distance of 2 pi. Okay? The arc along that circle has a distance at the length of 2 pi. When we do this, we go more than twice that far, almost 3 times that far, 5.4 pi, because we're moving this way at the same time we're moving in the circle. And how far do we move? Well, we move, as t goes from 0 to pi, we move 5 pi. So we're moving just a little further by the motion around the circle than we would move along a straight line between the 2 points. It's a very small distance, just 0.4 pi. Now, you might ask, well, if we move 2 pi along this and we move 5 pi along this, why don't we move 7 pi? Well, the shortest distance between 2 points is a straight line, etc. So I'm not going to explain all that because we don't want to digress too far. But it's worth thinking about. Okay? So it's kind of a good confirmation. If you straightened out this section of the helix, it wouldn't get that much longer. Okay? If you visualize it, and there's a picture in your textbook right next to the problem that shows you what it looks like. It's a pretty stretched out helix. It doesn't have that much further to stretch. So it stretches out from this distance, which is 5 pi, to a little longer, which is 5.4 pi. Okay? It stretches out by about 8%.